This video is an example of how you can do a proof like I'm asking you to do in this lesson. So the first thing is I already have written out here what I am going to prove. I'm going to prove exactly kind of the opposite of what you're proving. So for your proof, you have to prove that if this is an isosceles triangle, I'm going to put these marks here to show it's an isosceles triangle, that if it's an isosceles triangle and you have AD bisects BC is given, then you have to prove that AD is also the angle bisector of angle BAC. That's the proof you have to show. So you're going to have to show that these two angles are the same, given that these two lengths right here are the same. So my proof is the opposite. On this, I'm going to prove that if triangle ABC is isosceles and that AD bisects angle BAC, so I am starting with these two angles being the same, I am going to prove that these two side lengths right here also have to be the same, that AD bisects BC, segment AD bisects segment BC. So first, I already have that down, so when you do yours, you can already have that part written down. And then I want you to record yourself writing your name. So I'm just going to write on here that this proof is done by Mr. Peterson. There it is. Okay, so to start, I look at my given information. Triangle ABC is isosceles, so I can mark that there. What can I say because triangle ABC is isosceles? I can say that segment AB is congruent to segment AC because that is the definition of isosceles. That is the definition of an isosceles triangle. And I'm left-handed, so you won't be able to see what I write until I'm done writing. There it is. And then the next given information is that AD, segment AD, bisects angle BAC. So angle BAC is this angle right there. And if AD bisects that, that means that this angle right here and this angle right there are the same. They are congruent because that is the definition of an angle bisector. So the next thing that I'm going to state is that angle BAD, that's this one, BAD is congruent to angle CAD, that's that one. And the reason I'm going to say that is the definition of angle bisector. That's what it means to bisect an angle, is to cut it into two congruent parts. So there are my two congruent parts right there. So I have two things. If I were to write it off onto the side here, I actually have a pair of sides that are the same, a pair of angles that are the same, and I need one more thing to say that these two triangles are congruent. And the last thing that I'm going to take is that both triangles, triangle BAD and triangle CAD, both of those two triangles share angle or side AD. They both have the same side. So I'm going to say that segment AD is congruent to itself, because anything is congruent to itself. So the reason for that, there's actually a name. It is called the reflexive property. And chances are really good that when you do your proof, you will use that same reflexive property. So if the two triangles share a side, we can say they are the same. So that is my third thing. And so now I have that triangle BAD and triangle CAD are congruent because I have demonstrated that they have a side angle side congruence. So I'm going to write that down next. Triangle BAD is congruent to triangle CAD because of side, angle, side. We have a postulate that says two triangles are congruent if they have the same side, angle, side configuration. And we do here. So once those two triangles are congruent, that means all of the parts of those triangles are congruent. So angle B and angle C are congruent to each other. Angle BDA and angle CDA are congruent, but the ones we want is we want to show that AD bisects BC, which means we need to show that that side is congruent to that side. And in fact, we can say now that those two sides are congruent because the triangles are congruent. Here's BD and here is CD in the same place in that triangle congruent statement. So those two parts have to be congruent. So segment BD is congruent to segment CD because corresponding parts of congruent triangles are congruent. CPCTC. So again, that's corresponding parts of congruent triangles are congruent. If you need to pause the video and write down what that means, go ahead and do that. So now we can finally say that AD bisects BC because that is the definition of bisect. AD cuts BC into two congruent parts. We just said those two parts are congruent. Therefore, AD bisects BC, and that's the definition of bisect. So your proof, that's the end of the proof. At the end, the Romans used to write QED at the end of their proof, which means quid erum demonstratum, which is what we were trying to show. It was kind of like a ancient Roman mic drop. Bam, there it is. We showed it. So that is the proof. Your proof will look different than that. In your proof, again, you'll be given that these two sides, the AD bisects BC, so you'll be given that these two sides are the same. And you'll have to figure out how you can say the two triangles are congruent. I used side, angle, side. You will use something different. And then once the triangles are congruent, you can say that the angles are congruent. And once these two angles are congruent, you can say that AD bisects angle BAC. So your proof will be not quite the opposite, but kind of like the opposite of what I proved here. Please make sure you ask your teacher if you have any questions. Good luck.